Hello, my name is Dinah. And my talk is Science for the Sake of Science. All right. What is the purpose of science? Now, I know that's a hefty question, so let's take a step back. Let's take a step back in time to when we were kids and first learned how to ask a question. Mom, what is that? Dad, how does this work? Mom, why can birds fly and I can't? Why don't I get wings? That was a question that my mum could never fully answer. In those days, we were filled with the insatiable desire to know. It ran through our veins. It was question after question after question, with no end in sight. Why did we ask all those questions? Did we have an assignment due that night? Did we need it for our new job? Would the answers to those questions make us any money? No. No. We did something different. We pursued knowledge for the sake of it. We did science for the sake of science. Somewhere between now and those days that separate us from childhood, we have forgotten the joy and beauty of doing things simply because they intrigue us. Or should I say more accurately, we have been forced to forget. From a young age, we're told to pick a career that is sensible, something with job opportunities and transferable skills in case that industry falls apart by the time we've graduated. Ever since I was 7, I'd been dreaming of doing space science. I know, not very sensible. Actually, when I was writing the draft for this talk, my dad told me to include a story from back then. It goes something like this. In grade 1, we were given a piece of paper, and on it wrote, I was born to ... and we were told to fill in the blanks. I wrote, I was born to go to space. Now, when I learned that we weren't traveling to black holes or distant stars, I was thoroughly disappointed. So I made it my life goal to study these objects from afar. People around me, sometimes close friends and family, would say, what's the point of what you're doing? What benefit does it have to us here on Earth? And the most painful question of all, is it even profitable? Now, I'm all for questions, so today I would like to make a case for curiosity by answering them. I would like to show you the importance of science for the sake of science. Let's begin with something we're all familiar with, the Pythagorean theorem, the classic a squared plus b squared equals c squared. Now, I can't see everyone in the audience, but hands up if you had to learn that in school. It's pretty much everyone. Keep your hands up if you ever thought to yourself, why am I even learning this? Yeah, don't be shy. It's a majority of us. Oh, without the Pythagorean theorem and other fundamental geometric laws, we wouldn't be able to build skyscrapers or bridges that connect islands or even the roofs of our modern homes. Okay, that's cool. How about something a bit more abstract, like complex numbers, also known as imaginary numbers? Now, what on earth could imaginary numbers have to do with real life? Turns out, quite a lot. They're used in alternating current circuit analysis, and by extension, in the production and redistribution of power. Imaginary numbers literally keep these lights on. Mathematics is the most pure form of science. It takes decades, sometimes even centuries, for us to discover the applications of these abstract theories. Historians say that complex numbers, specifically the square root of -1, was brought into the world of mathematics sometime around the 14th century. Only 300 years later, in the 19th century, did we discover the widespread application for them in physics and engineering. Most mathematicians don't even get to see their work brought to life. They die before then. But it doesn't stop them. It doesn't stop them from asking questions and dedicating their whole lives to finding an answer. Why? Why are they like this? Well, humans are inherently curious beings. We've put one foot in front of the other and traversed continents. We've sailed all the oceans, and still that wasn't enough. We wrote novels, pages upon pages of new fantastical worlds to explore. And still, that didn't satiate us. Ever since humanity has existed, we've been looking up at the sky, wonderstruck. I know every one of us in this room has at one point been in awe of a sunset or the full moon. Aside from providing an abundance of inspiration in art and literature, venturing into space has led to some surprising technological advancements that we use in our everyday lives. Okay, I'm going to act like a middle school teacher again, so hands up if you have a cell phone. And if you don't have one, I'm jealous of you. Now keep your hands up if you've ever taken a picture with said phone. Yep, that's pretty much everybody. Well, you might be surprised to know that phone cameras are a relic of space travel. In the 90s, an engineer from the Jet Propulsion Laboratory invented a digital image sensor based on a special type of semiconductor. Now, this image sensor was more compact and more efficient than those of its day. It allowed NASA to take high-quality scientific images, and eventually, this technology enabled tiny cell phone cameras to exist that we all use today. But it doesn't stop there. Compact water filters, freeze-dried food, scratch-resistant lenses, and even infrared ear thermometers are all derived from space tech. Another good one is the clothing material that firefighters use that's heat-resistant. Well, that was first used in spacesuits to protect astronauts from the extreme conditions of space. Pretty cool, right? Looking further into the distance, past the moon and Mars, we find that the field of astronomy has some fascinating connections with the medical field. Let me give you an example. One way of observing the vast universe is through the use of X-rays. Now, to design a telescope for this, we have to understand how X-rays are different from other kinds of radiation. Put simply, X-ray photons have much more energy than visible light, so if we were to shoot them at a standard mirror, they'd pass right through. To get them to bounce off and into a detector, which is what we need for the telescope, we have to orient them at a very low angle. This is high energy radiation we're dealing with, so it's by no means an easy task. All the progress we've made in the field of precision X-ray optics has allowed us to engineer cancer treatment tools that focus high energy radiation onto tumors while leaving the surrounding tissue unharmed. These innovations, they are saving lives. And considering all this, you could still say, Diana, we're living through a climate crisis. We need to focus on our own planet. And I'm with you. I wholeheartedly agree. If we zoom out and take a look at this argument from a different perspective, we start to learn just how critical space science is in keeping our planet and its inhabitants safe. Take the thinning of the ozone layer. That was discovered with the help of satellites. Governments from all around the world came together to sign the Montreal Protocol, which to this day protects the ozone layer from harmful chemicals. Another purpose for satellites is to give us high-quality data from areas affected by natural disasters. From floods, fires, earthquakes, and cyclones, satellite networks allow us to alert communities, giving them enough time to evacuate. In the aftermath, they help search and rescue parties find the quickest and safest path to victims. Unfortunately, Australia has had its fair share of bushfires. For a moment, imagine the devastating impacts if we weren't able to see the early signs of fire from space. I know that's all well and good, but there are still some people who are not on board with this kind of science for the sake of science. They think that we should be looking for something that's profitable. But we have to ask the question, profitable to whom? And it is a simple question, but it's often left unanswered. The idea of what is profitable is actually dictated by a very small group of people who are never the scientists themselves. And yet, they are the ones who decide which projects get funded and which ones have their funding stripped away from them. If we were to follow only the profits, we wouldn't have made so many of the discoveries I have mentioned today. That's because their value does not lie in the monetary gain of a select few, but in furthering human knowledge, something which can never have a price tag attached to it. The value of science for the sake of science can simply be in inspiring the next generation. It's the wide smile of a kid the moment they decide they want to be an astronaut when they grow up. It's curiously climbing a tree one day and doing forest regeneration work a decade later. It's holding your mother's hand in the hospital and knowing that you belong in medical research. It's international collaboration and fuel for our imagination. It's beautiful and messy and complicated, and we don't know what we might find. It might be a dead end. But we will never know unless we dare to look up and wonder. Thank you.